Hi, let's talk about the effective point of measurement. This topic confuses a lot of people. It all comes down to how we align our chamber at some depth, represented here by a line. The center of the chamber, or the electrode, is called the point of measurement. What TG-51 calls the effective point of measurement is located above or upstream. So which way do we have to shift our chamber if we want to align to the effective point of measurement? We have to shift our chamber down. TG-51 tells us two equations, one for photons, one for electrons, to how much we should shift by. For photons, it's 0.6 times the radius of the cavity. For electrons, it's 0.5 times the radius of the cavity. And remember, we only shift when we're measuring KQ. We do not shift when we're actually performing the measurements for photons. The TG-51 calibration is still at 10 cm point of measurement. Now, let's take a look at a practical example of setting an ion chamber at a water surface. Using the point of measurement, we let the software make the shift for us. We're going to go down below the water surface, and then we're going to go up, and we're going to match the reflections. When the reflections match, that's when we're at the surface. Now let's go back and talk about, or try to get some sense of intuition about why we have to make a shift a little bit deeper when we're using a cylindrical chamber. Well, if you think about it, if you're trying to measure at some depth, let's say 5 cm, and you displace a small amount of that water with air for your ion chamber, it makes sense that you'd have to shift your chamber a little bit deeper in order to represent that same depth.